And coming to you from the plush studios of Way Happy, it's Mr. Meyer. Hey, thank you, and welcome to our our last two sections of Pre-Calc Chapter 5. We are going to do the law of sines, law of cosines. Now, last try I had to pound these into one day. Well, we're a little bit ahead, so I get to do just the law of sines today, and then tomorrow we'll do law of cosines. So even though your notes have both, I will only do one today. So we've been solving right triangles, and the thing is, what if the triangle's not right? You can see on my screen that drawing I have, that's not a right triangle. And so triangle ABC here is not right, and it's not wrong either. So if you want, we could derive the law of sines. The law of sines helps us find all the sides and all the angles of that triangle. Just to show you where the formula comes from, right triangle trig is right there. You know, you just pull this guy straight down and you've now messed up angle C, or I'm sorry, side C. But you've created two right triangles, which would help us a little bit because, like, look, I could take angle A and I could say, let's call that height there H. So the sine of angle A there would be the opposite, H, over the hypotenuse, in this case B. Now look, I've also done something for big B over here. I have the sine of angle B is equal to the opposite H over the hypotenuse A. Now, kind of cool here is that they both have an H in them, right? So we can set them equal to each other according to H. So I think the first thing I would do is say H equals little b sine of A, while H over here equals little a sine of B. And now I can set them equal to each other and say B sine of A is the same thing as A sine of B. Now it looks a little weird because, you know, you got this B and the A on one side and the B and the A on the other side. So why not try to get them together? I'll just divide both sides by AB, assuming AB is not 0, or A or B are not 0. And notice these guys cancel, and you have sine A over A equals sine B over B, and I could do the same thing if you wanted me to throw in sine C, and you would learn quickly that sine C is equal to C, and all those ratios are true. So there you have it. The law of sines, you can write it either way. The sides on the top and the angles on the bottom, or the angles on the top and the sides on the bottom. You just can't mix it up halfway through the problem. So stick with it. I usually like it if the thing that I'm looking for is in the numerator. That's what I'm saying right here. So if I'm looking for something like a little a, then I'm going to use the top formula. If I'm looking for an angle, then I'm going to use the bottom formula. Now law of sines works great for angle side angle, angle side, side angle. All stuff that you learned in geometry that said, hey, if you have this, one triangle exists, and you're like, yay, and you know, it wasn't that useful before, but now it's going to come in pretty handy because we are going to talk about that side angle situation. But we'll get to that. So let's just do the law of sines. Here comes our law of sines, right? So I give you a triangle, and I say you have this triangle. So go ahead and draw a triangle on your screen, and you would then say, label the sides. Now remember, we use large letters for angles and we use small letters for the sides, and we try to keep the sides opposite the angle, make them corresponding. So little a would be right here. I know big A is 32 degrees. I know that big B is 45 degrees. And so now I'm ready to go. Now there's one thing about the law of sines that you have to know. The law of sines always requires that you have some magic pair, that you have a side opposite an angle. And if that's true, you're good to go. Don't have it there. Oh, but wait, I do have it right here. And sometimes you may have to know that, you know, 3 angles add up to 180 on a triangle. So you may have to actually figure out that third angle before you get your magic pair. And sometimes you won't. But we do have our magic pair. And that's awesome. So I'm going to go shoot for little b right now. Now I'm looking for little b. Means I'm going to put the sides on top. Just personal preference again. So here we go. 9 over the sine of 32, that's my a's, is equal to little b over the sine of 45. And now I'm just going to solve this. Cross multiply and solve, or move sine 45 to the other side, and you're done. You get 9 sine 45 divided by sine of 32, and you jump up and down. That's going to be your b. So you grab your calculator and you type it in. So 9 sine 45, actually could have done that without the calculator, divided by sine of 32, couldn't have done that without it. I should probably check my mode to make sure I'm in degrees, which I am. And I hit enter, and I get 12.009. Let's go with 12 for the sake of this argument. But we get side B is 12 units long. If you want to go 12.009, you know I'm a big fan. So we get side is 12. And now we just have the C's that are missing. And hopefully in the back of your brain, you're like, wait, sides of a triangle add up to 180. So let's see, these two add up to, what is that, 77? So I'm missing 103 degrees. So I'll put that in. This has got to be 103 degrees. As you can tell, my drawing is not drawn to scale. And now I can use the law of sines one more time. Again, I can take side A, the one they gave me, 9 over the sine of 32 is equal to side C over the sine of 103. And I will grab my calculator and I will just type that in. So again, 9 sine 45 divided by sine 103. Oh darn, couldn't do that trick at all, could I? I have to put it in there. Second insert 103. So I got lazy. Tried to type it in so I wouldn't have to, and boom, there we go, 16.55 units, and I will have my sides 16.55, and I'm good. Look at the sides, look at the angles. Remember little things from geometry like the largest side should be opposite the largest angle, and in my case they are. The smallest side should be across the smallest angle, and they are. So I'm feeling really good. Even though my drawing's not perfect, my measurements are. And so I feel very happy. In fact, way happy. And why don't we go ahead and ask you a quick question? Excellent work. How about YouTube high five? Woo, good job. All right, so now we've seen the beautifulness of the law of sines and how it helps us solve right triangle or non-right triangles. Now let's talk about that case we never got to talk about in geometry, the mysterious side-side angle. Ooh, why wouldn't they tell us anything? Well, because every theorem they gave you, every postulate, every whatever they call them in geometry, whatever they gave you, it always said that if you have this and this and this, a triangle exists. And you're like, okay. And they give you another one. They're like, if you give in side, 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 a triangle exists. And you're like, okay. And then they would never commit to side-side angle, or more inappropriately, angle side-side. But you know what? It's easy to remember that way. Angle side-side is a total pain in the neck, right? So be careful. If I give you an angle side-side problem, what does that mean? That means I'm going to give you an angle. So here's angle A. I'm going to give you this side. We'll call it little c. And I'm going to give you one more side, little a. And there's a chance that little a is not big enough. I just gave you some information and it's not good enough. Little a can't even reach that other side. That dashed line was there because I knew the angle. I just didn't know how long that side was. And so the thing is that little a is just hanging there going, please, I can't reach. And so what happens is I gave you information, angle, side, side, but no triangle even existed. And you cry, right? Or there's the case that I give you angle A, and I gave you side C, and I give you A, and it just happens to come down and whack, hit that right there, right angle, right? And you're like, sweet, there is one triangle that I can draw. Well, you can see trouble already. Why did geometry not like this? How could you give me angle, side, side, and there be no triangles or one triangle? You're not committing. Tell me which one it is. Well, we don't know, right? You never know. Well, it gets even crazier. There's a chance that I give you angle A, that I give you side C, and I give you side A, and you're like, sweet, it's just that long, however long it is, and it just reaches, and therefore there's a triangle. And then the person next to you goes, oh, dang, you drew it like that? I drew that side like this. Notice they're both still A, and they're both still the same length. And yet you two are talking about two different triangles, right? One of you is talking about a very obtuse triangle, while the other one of you is talking about an acute triangle. Holy macaroni, that means there's two triangles with the given information, and that's not fair at all. So that's why you have the ambiguous case, right? The ambiguous case says, look, if somebody gives you angle side side, draw the picture, look at it and go, oh no, right? There's a chance that it doesn't exist. There's a chance that it's just one triangle like always, or there's the off chance that there's two triangles and I got to solve for both triangles. So angle side side truly is a pain in the neck. All right, now that we got around that, let's talk about it. You're going to do it just like you do law of sines. Somebody hands you angle side side, you're like, sweet. So I got the same drawing here. I'm like, okay, angle A is 30 degrees. And I got a little, let's see, C here. That is 4.5. And then I got A, which is, let's just call it 3. And I'm just going to assume that there's one triangle or whatever. I just assume there's one triangle. I just draw a triangle, and I'm just going to see if there's an answer. Now, if my calculator or something doesn't add up right, and there's none, then there's none, right? But let's see. So law of sines, I look for my magic pair, and I'm like, sweet, magic pair right there. So law of sines is going to be a happy camper. I'm going to say, what am I looking for? I'm looking for an angle this time. In fact, I'm looking for this angle, which we call C. So I'm going to put my angles on top. So I will do the sine of 30 degrees over 3 is equal to the sine of angle C over 4.5. And I just go ahead and I cross multiply, or I multiply the 4.5 over to the other side, and I'm very happy with myself. And I have sine C. Now notice, to move the sine to the other side, I'm going to have to arc sine. And then I arc sine that, I will get angle C. So I grab my calculator, and I have my calculator ready. I go arc sine of, here, I'll use the fraction button, so alpha F1, numerator, denominator, 4.5 sine of 30 all over 3. And I hit enter, and my calculator says, hey, it's 48.59 degrees. Way better answer than 48.6, but there we go. C equals 48.59 degrees. And I'm so happy I can now continue on, right? Now that we have angle C, 48.59, we can now find angle B because they got to add up to 180. And then I can use the law of sines to go ahead and find side B, and I'm finished. But here's the one step I want you to do every single time you're given an angle side-side problem. First, notice it's an angle side-side problem. For those who don't, we're like, dang it, they're going to miss this step. But if you ever notice it's an angle side-side problem, realize that it could have not had an answer. Looks like we got one, so we're feeling pretty good. Also realize that there could be the two triangle situation. So I always wonder, is there a second triangle? Well, the cool thing you might notice from my drawing up here is that two triangle solution, this angle and this angle must be equal, right? They have to, because they both have side A. And so that means that this guy is the supplement to this guy. So those two angles should add up to 180. So if the second triangle does exist, and if and only if, right? The way I could find that second angle is whatever you found the first angle to be, 48.59, really quick, find its supplement. So in the second triangle, if it exists, its angle C would be 180 minus 48.59 degrees. Or what is that? 131.41. 131.41 degrees, right? So now I have a second triangle, and the same thing is going to happen that I would have done on the first one. I'm going to make all three add up to 180, because remember, this stuff is still true. Big A is still 30 degrees because that was given to us. Little a is still 3. Little c is still 4.5. That's all true on this triangle. So I can now also go find angle B, and I can find little side B just by using the law of sines. So law of sines, I'll check to see if there's, the one triangle. If it works, awesome. I'll check to see if there's a second triangle. Now remember, this is only if you are given angle side side. It's not in any other case. They have to be in that order. If somebody gives you side angle side, You don't care about that second solution. You only care about that first solution, and you're done. You don't even have to think about it. It's angle, side, side that is the big pain in the neck. All right, and for you completionists, let's figure out that first triangle, and we can go back and figure out the second triangle too, just so we have it all done. So remember, on that first triangle, we have a 30-degree angle. We found the 48.59 degree angle. So that means that the other angle, they all got to add up to 180. So that means that angle B has to be 10141. So 101.41 degrees. And now I can just use the law of sines, and I can be happy that I have it all set up. I got 3 over sine 30 is equal to little b over the sine of 101.41. I'm going to grab my calculator. It's going to tell me what that final side is. So 3 sine 101.41 divided by sine of 30, and my calculator screams out it is 5.88, and so therefore little b is 5.88. And I find some way to present my numbers pretty. There's little b, there's big B, there's big C, and the other 3 were given to me, so they are all found. You know, you could even write them next to it on the problem, so you have everything you needed. And that was one triangle solution. Now we know there's a second triangle because we found the other angle, so let's finish that one up too. So what I'm going to do there is set up the second triangle. Notice we still have the same given information, and we know that this angle was 131. So since I know that that's 131 and that's 30, that's 161. So I'm about 20 short. So that was at 18.59. So I am 18.59 degrees short of that last one. And now again, I'm going to use the law of sines. I have 3 over the sine of 30 is equal to little b over the sine of 18.59. And I'm going to cross multiply that. So I'm going to have 3 sine 18.59 divided by sine of 30. And lo and behold, 1.91 is that measly little side. 1.91, which makes sense. It's the smallest angle. It's got the smallest side. The largest angle, C, had the largest side on triangle 2. On triangle 1, all that stuff's true, except for it's a little different. Largest side was B with the largest angle, and smallest was definitely A, I believe. Yeah, A with the smallest side. Hope that works. Remember law of sines? You can always do it. Just be careful about angle side side, or side side angle if you want to be a little more appropriate, but be careful about it because that's the one that might not exist, or it might exist, or it might exist twice. So no wonder geometry couldn't say it's a triangle, because no one knows. It's very ambiguous. It's very mysterious. Have a great day and stay happy.